Okay, we'll get started. Happy Friday, everybody. Week 8 is over, and well, just about. And then next week is Thanksgiving week, so I'm just going to lecture on Monday. I don't know, did your other classes cancel on Wednesday also? Everybody? No? No? Okay, well. Huh?
Not 42.
All right. Okay, well, all right. That's all right. So anyway, let's take a look. We didn't finish up this part on Wednesday, so we'll finish this part up, and then we'll go. Okay. So anyway, this is all taken from Alan Downey's Think Python book, Alan B. Downey, and there's just a few kind of things that Python does that just make our life easier or make our code a little bit more elegant or simpler. They're not necessary. Like Python could have been totally fine without putting in these little features, but these are some of the things that that Python does, and I think one of the reasons why Python is kind of this the preferred language for a lot of just like short, quick little scripts, okay? Is it the fastest language with the highest performance? No, okay? But if you need to write something quickly to get a task done, yeah, Python's going to be pretty great. So we have things called conditional expressions, right? And basically, you know, we have if statements, right? And we're used to kind of conditional statements and things like that. But you can kind of make things a lot easier. So, okay, so here I've got x is -3. And let's say I wanted to calculate the log of some kind of number, right? And if I tried to just do math.log of x, okay, we're going to get an error, right? It says you can't take the log of a negative number. So we have, you know, we might do some kind of conditional expression or conditional statements where we say if x is greater than 0, then go ahead and take the log of it, and otherwise return nan, okay? And if we do that, then we have y. Okay, now we can you can do this, okay? And you can kind of make it, you can just do y is equal to math log x, okay? And then you put in kind of the conditional statement here, right? If x is greater than 0, okay? Otherwise, make it float nan, right? I don't know if this is like, I think we're accustomed to seeing this, so this is like easier for us to read, okay? But at the same time, this is kind of how we speak in English, right? So if you think about like how you construct a sentence, at least in English, you'll say like, hey, do this if this, otherwise do that, okay? And this is kind of a way to express that. Again, you know, as programmers, we're like, oh, you know, if this, then this, otherwise do this. That's fine, okay? But this is also a way to do it, okay? And this is especially, this is really, you should only use this when it's like just assigning a value, okay? It's not meant to replace if and else statements for code chunks, right? If you have an if statement, you're going to do a whole bunch of things, use an if statement. But this is just kind of like, if the only thing you're going to do is assign a value, then the if statement makes sense there. Okay, so here, you know, what is the log of e? 1, okay? If we try to do it with -5, we get back nan. Okay. Similarly, here you can even do kind of include it in like a recursive statement. All right. So here, the factorial function can be expressed as a recursive function, where basically you do n times factorial n minus 1. The base case is when n is 0, then you're going to just return 1, okay? And so you could do that. Factorial of 5 is 120. You can also just do it like this, okay? Define the factorial, and then you just kind of expressed it in a single line here, okay? Now, I don't know. This is probably probably easier to read and understand than this, right? Sometimes you get a little too clever for yourself, and you're like, oh, I can take advantage of this feature, and then you write some code that just becomes unintelligible for everyone else. So, and then also unintelligible for you when you revisit your code 3 months later. So don't be too clever. But yeah, you could use it, as part of a return statement if you wanted to. Okay, and it would also work. So here, factorial 6 gives us 720 and things like that. Okay. We've seen this already with when we talked about tuples. You have the star to kind of gather and scatter, and so here I could do star args, and this will take whatever we put in and gather it into a tuple. Okay, and so I can do this, and so here is just kind of a silly dice function. Okay. And the idea here is, I don't know if you've ever played a tabletop game where you have a bunch of different dice. So sometimes they'll say roll a d6, which is a 6-sided die, okay? Or they'll say roll a d20, which is a 20-sided die, and things like that. And then you got d4s and d8s and d whatever, different shaped, different sized dice. And then you might want to say okay, roll these things, roll a d20 and a d6 and add those two things together or something like that, okay? And so what we can do is we can do this, write a function, takes in an argument star dice, okay? So it can take in multiple numbers, and what this function will do is it'll accept how many sides the dice are, and then and it will roll each of them. So your total is it's gonna return the total of the dice, and it will print out, tell you what the different things are. So for example, roll 20 is going to be rolling one 20-sided die, and it will say you rolled a 3, and the total is 3. Okay. Roll 6-6-20 is roll 2 6-sided dice and one 20-sided die, and it will tell us the outcomes of each of these things. So it says I got 6, 3, and 11 for a total of 20. I could try running it again. Oh, look at that. I got the 111, which is like a feat in of itself. In like D&D, this would be the total epic disaster. But here we have 3, 5, 18, and you get that, so on and so forth. Okay. And so you can do that, roll a 4-sided die, a 6, and a 20-sided die. And so again, we are allow for a variable number of arguments. They get gathered together into a tuple, and then we iterate through that tuple there. Okay, and similarly, we can do things with basically dictionaries. Okay, so we have star quargs, keyword arguments. Star meaning we're going to have a pairing. We're going to gather things together into basically a dictionary, and the convention is to use quargs, keyword arguments, and star args. But again, it doesn't have to be particularly named args or whatever, or quargs. So anyway, we're going to gather things up together into a dictionary, and then I'm going to just print key has blank value. I'm using the old-fashioned thing. I could do this. Key has value this, and then I do dot format. Okay. So we put in our our placeholders, and then we plug in the things. Okay, so we have CA is California, OH is Ohio. Those get gathered together, We can zip them together to a dictionary. So here I have CAOHTXWA for California, Ohio, Texas, Washington, and this is what my dictionary looks like. Okay. Now, if you just pass the dictionary directly, it runs into a problem because it's expecting this. So you have to kind of explode the dictionary or scatter it using star on the D, and then it will work just fine. Okay, and then you can kind of do it directly by doing star dictionary zip key and names here. Okay, and so on and so forth. A popular use case of using this variable keyword arguments is, for something like matplotlib, if you have a bunch of settings that you want to use, okay, you can create a dictionary with all of the settings, okay, color blue, line type 2, line width 3 or something, and you can create a bunch of plots with the same set of settings, and you just kind of pass this dictionary in as star quarks. Okay, more stuff from Python, okay? So some of these things are taken from that Fluent Python textbook. And so, we have something called a named tuple, okay? So named tuple is basically a shortcut for defining a new class, okay? So it's kind of like defining a new class where really the only thing you want it to do is to just contain values, but you want to give those values names, okay? So, when we did cover a lesson on object-oriented programming, we created a class called point, and that class point had basically two attributes, self.x and self.y, and we just gave those things values, okay? Here, what I'm going to do is I'm going to import something called the named tuple, right? And a named tuple is basically going to be able to do this just in a very kind of simple form. And this is useful if you don't need to do anything other than, kind of store these values, okay? So I'm going to create something called named tuple. And here I'm going to create basically a new class called capital P point. Capital P point is going to be a named tuple, okay? It's going to be called a point, and the values will get have the labels X and Y, okay? Two values with the labels X and Y. So P is going to be _main.point. And so now, if I want to create objects of the point class, much like before, I just call capital P point, and then I pass the arguments that I want to pass. So this is kind of like how I had to kind of define the _init. And now what is P? It says P is a point class with X equal to 1 and Y equal to 2, right? And so this is basically, we get almost the same functionality as this, okay? But I didn't have to create _init and _string. I just call named tuple, and I say what are the things I need to store, and it creates it that way, okay? And so basically, a named tuple can be used to kind of store like information for records, okay? So there's a question of like tuples versus lists, and tuples are immutable, right? Once you have it set, you can't sort a tuple, okay? Directly. You can give a sorted version of the tuple, but you can't really modify the things of a tuple. And so tuples can also be used as a way to kind of record information, okay? So for example, let's say we wanted to record information about students, and we could say, the first field is their first name, second field is their last name, third field is their age, and the fourth field is their GPA or something like that, okay? And because you know everything's always going to be in that order, you can, write functions or whatever that take advantage of that structure. Whereas a list, you might have the same thing, but then with a list, it might get modified, right? Like they might sort the list, okay? They might do something to the list where now you can't always expect the information to be properly formatted. Okay, and so tuple fixes that, and then a named tuple basically just applies names to each of those things. So you can have first name equals this, last name equals this, grade, GPA, whatever. Okay. And then now that we have the named tuple, you can still access all of the values here. Okay, p dot x is 1, p dot y is 2, square bracket 0 is this, and because it's a tuple, it inherits all of the methods associated with tuples, okay? Such as comparisons. So you can compare tuple 1 and tuple 2, or point 1 and point 2. It's going to do a 0 versus 3, then a 1 versus a 4. So P1 greater than P2 is going to come back false. Now, what happens when you do addition with tuples? Okay? So addition with tuples concatenates tuples together. Okay, it doesn't actually, it's not like a vector where you're adding 0 to 3 and 1 to 4 or something like that. Okay. Here I can create a list, and it will give us the points, the named points there. I can say, hey, give me back the sorted version of the list, where it's going to basically sort on X first and then sort on Y, okay? And then, so let's say you say, hey, you know what? I like the fact that we have this named tuple, but I don't like this addition property, right? Tuples, the way when we do add them, I don't want them to concatenate. I actually want to add the X and the X together and the Y together, okay? So what you can do is you create the named tuple called point, and then we're going to define a new class called vector, which will inherit from point, which is a named tuple. And I'm just going to add in this this method, double underscore add. And what this is going to do, okay, is it's going to return a vector where the new x is going to be self x plus other x, and y is going to be self y plus other y. So now I can create vector 1, 0, 1, vector 2, 3, 4, and I can create vector 3, which is the sum, or is that what we call it? We sum the vectors? I don't know, v1 plus v2, and then so v3 will be what, 3 comma 5, right? So this is a 3 comma 5. So this is neat, right? I don't know. I think it's neat that we just create a named tuple very quickly, because if you think about like what were the actual lines of code, all I needed to do was define this thing, point being a named tuple, and then if I wanted to expand on the functionality, I just had vector inherit from that, and then I added just a couple of like 2 lines here, okay, to have the double underscore add method there. So that is so that's named tuples. It's a really quick and easy way to get some new classes defined. Okay, we have there's some kind of cool things in the module called collections, and one of the things in collections is the counter. Okay, and so this is useful if you have like a big list and you want to say like how many times did a certain element appear, okay? So, or if you have like a big text document, all right, you can easily, you could split the text document on the spaces, okay? And that will kind of return a list, and then you can call, counter on the list here. So here I've got a list of strings. I've got red, green, blue, okay? And I want to get a count of how many times each of these things go. So I just call counter, capital C counter, on the word list, and it returns back basically a dictionary-like structure. It's called a counter, though, okay? A structure called a counter, where it has gone through and it has tallied up each of these things. It says blue showed up 3 times, red showed up twice, green showed up once. And then the counter has a few functions built in here, like what is the 2 most common values. And it says blue, which showed up 3, and green, which showed up twice. Okay. I can say, how many times did blue show up? It showed up 3 times. Okay. And you can apply counter to any iterable. So here, I did it to a list, but you could also do it to the string. Okay. And a string is an iterable of individual characters. So I have A, B, C, D, D, E, F, G, A, B, C, D, J, I, L, K, H, A, B, C. All right, and I say count this up. All right, and it says, okay, A shows up 3 times, B shows up 3 times, D shows up 3 times. All of these other things show up once. Okay, I said she sells seashells by the seashore. Dot split. Okay, so dot split is going to take this string, split it on the spaces, make a list. And then I can say, hey, make a counter of that. And as much as it looks like there's similarities here, the only word that shows up twice is C. And everything else just shows up once, okay? So anyway, that's what we have there. All right, so that's a counter. Just kind of a quick handy thing, If you forgot this existed, you'd probably have to write a loop, create a dictionary, and you'd say if this key exists, add 1, and if it doesn't exist, create a new key. And you could do that, and that'll work fine. And I actually think I made you do that for one of your homework assignments, right? Maybe, I don't remember. But yeah, so this solution exists too, just running the counter. Have I given you any view quiz answers yet? No. Okay, let me give you your first one, which is the letter E. E as in elephant. E as in elephant. Okay. We also have something called a list comprehension. A list comprehension is basically a way to create a list using just a simple expression here, okay? So traditionally, if you wanted to kind of iterate through some kind of iterable and then take the results and put them into a list, you would have to do something like this. You'd create an empty list, and then you'd go for each thing in the iterable or the collection, and then you'll do results.append whatever expression you have, okay? Maybe you even have a condition. And that can be simplified into, let's make a list. What's going to go inside? Whatever expression you have for each value in the collection. You can even put in a condition there, okay? So this is, I could do store x star 2, basically x squared, for x in range 1 through 11. So it's going to go through 1 through 10, and it's going to store x squared. So it's going to go, 1, 4, 9, 16, up through 100. Okay? 1, 4, 9, 16, 25, 36, up through 100 there. Okay? You could do it as a NumPy array as well. And it does that too. If you want to apply a condition and you say, hey, I only want it for like the odd numbers or something like that, you can just put in a conditional statement there. Okay, if x mod 2 is equal to 1, okay, and then now you just get the odd squares: 1, 9, 25, 49, 81, and stuff like that. Okay, so this is called a list comprehension. So I'd say they're fairly popular. So when you read someone else's code in Python, you will probably encounter a list comprehension, because this is just kind of a much more elegant way than writing, start off with an empty list. Here's a for loop where we go through each entry here. Okay, here I have, what is this going to do? Okay, I've got a list of strings, A as bat, car, dove, python. Okay, and what we're going to store is x.upper, so we're going to capitalize everything, make everything uppercase, and we're going to go basically for everything in the strings, but only if the length is greater than 2. So only if the word has more than 2 characters. So we're going to ignore the A and the as, but I'll get capital bat, capital car, or uppercase dove, uppercase python here. And that's what we have, bat, car, dove, python. Okay. If you want, again, the dot split applied to a string will split it on the spaces. Okay, so I could take each individual word, capitalize them. Okay, and so now we'll have all of this, and it'll feel like we're shouting here. But we have the words she sells. There you go. Okay. What are other tongue twisters that Peter Piper? I don't know. How much wood could a woodchuck? Is that a tongue twister? Is it a woodchuck? I don't know. All right. Is that a real thing? Okay. All right. What if I want to do this, right? So I can take this string. We're going to go through each character in here, and then we're going to check if that character is a digit. And if it is a digit, we want to turn it into an integer. We don't want the string with string 5 in quotes, but we want the number 5. So here I'm going to extract out all of the digits here, and so I get 963257, so on and so forth. Okay, you can also go over a dictionary. So here I've got a dictionary. And then we can make a list out of the items, and then we could iterate over this, right? And so blank is for blank for each of these things. Yeah, at this point, I don't know if this, again, don't get too clever for yourself. And so if your list comprehension starts to get really unwieldy, maybe a traditional for loop is a better choice, okay? And that's what we have here, okay? So here I say do this for this as long as it's not B or D, and so we get A is for apple, C is for carrots, E is for eggs. C is for carrots, who chose that? C is for cookie, and that's good enough for me, okay. Now, the song is cookie is a sometimes food. I don't know. All right. Okay. More things that you can do with a list comprehension. So this this is when things get wonky. But if you want to create like a combination, right? You want to match. So here I have card ranks, ace, king, queen, jack, and the card suits, clubs, diamonds, hearts, spades. So, when we created the deck, we said, for basically each suit, also go through the ranks, and we made sure we created basically every combination. You can do the same with a list comprehension. Again, I don't know. Is this easier? Easier to understand? I don't know. It's basically a nested loop. So you say, hey, give a tuple of rank and suit for rank and card ranks, and then for suit and card suits. And when you state it like that, you will get this. Okay. So I get ace clubs, ace diamonds, ace hearts. Okay. This looks almost exactly the same. But here I'm going to do for suit and card suits, that followed by for rank and card ranks, okay? And then so when you do that, okay, notice how the order changes. This is it's maybe a little tougher to comprehend, but yeah, it'll create a recombination there. So there's 16 tuples in here. Okay, dictionary comprehensions, same exact thing, except you have to provide an expression for the key, an expression for the value, and you have something like this, okay? So I can take this list, apple, mango, banana, cherry, and then we're gonna have the capital of the word and then how many characters are in the word, okay? So apple has 5, mango has 5, banana has 6, and cherry has 6. It feels strange that banana and cherry have the same number of letters, but that is, as we have, what's the longest name of a fruit? Pineapple? I don't know. Longest fruit name? Huckleberry? I don't know. Is that a fruit? I'm just making things up. Something. All right. Fruit. I'm so tempted to just open up the internet and say, what fruit has the longest name in English? Okay. Blah blah blah. All right. Here's this. Okay. We've already seen enumerate. Enumerate zips. Basically a range object with everything, and so here we've got this 0 gets mapped with A, 1 with S, and so on and so forth. But enumerate's super handy little thing, and so here I can just kind of take this and then make a dictionary out of that. Okay, so now what we had here, we have that. Okay. What did I do here? Oh, here I'm swapping, okay? Swapping the position, the value on the index here. And so I have another dictionary, but now the word is the key, right? And so if I wanted to look one thing up or the other, if I tried to look up this thing with the A, it doesn't work, but the location mapping does, and then we can kind of combine these two together by doing all of this. Okay. All right. What are generator expressions? Okay. Generator expressions are basically like a list comprehension. The only difference is rather than putting a square bracket, notice I'm using parentheses. Okay. So it's like it feels like we're making a tuple comprehension, but it's not a tuple comprehension. It's called a generator expression. So imagine writing a list comprehension, but instead of putting square brackets, you do parentheses, okay? What is the difference between a generator expression and a list comprehension? Generator expressions are lazy, okay? Which means they will not go through, this part that says for n in range 12, a list comprehension is gonna go through all 12 from 0 through 11, figure out the results stored in a list, okay? A generator expression will not do any of that until you ask for it to do, okay? So when you ask, what is G? It just says, hey, I've got a generator object. And then you say, okay, what is the next value? Okay, it starts off with 0. What's the next value? 1 squared. Okay, what's the next value? 2 squared. What's the next value? 3 squared, so on and so forth. And then you can say, hey, iterate through the rest of it, and you get the values, for 11. Once you reach the end, and you say, hey, what's the next value? It's going to say, hey, I've run out of values. Okay, I've run out of values. Okay, what's the difference here? Okay, both of these things look almost exactly the same. The only difference is this has a square bracket, and that's a list comprehension. This is parentheses. This is a generator expression. Okay. The list comprehension, it's going to evaluate 1 through 1,000. It's going to do the whole thing, okay? G for range, or 0 through 999, and this is range 1,000, also 0 through 999. The generator expression is lazy, okay? It's not going to do it. So if you ask what's the type, this is a list, and this is a class generator. That's no surprise there. The key here is that it's basically the difference between I tell you write 0 through 999 on a piece of paper, and one person actually does it. And then the other person just says, I don't know if they're actually, if they actually need this thing, right? I'm just gonna wait until they actually say I need it. And then if I need it, then I'll give you the answers, okay? And so if you say, hey, how much space does this take up in memory? The list actually, takes up a lot more space because they actually did all of the work and wrote all of these numbers out, okay? Whereas the generator expression just says, all right, I will get to it when I get to it, okay? The difference, however, is with a list, because everything has been calculated, you could say, hey, what is the fourth value, okay? And the list will tell you what the fourth value is, okay? Whereas the generator is not going to know because it says, oh, I haven't gotten there yet, okay? Because it's just going to do things one at a time, okay? But you can still kind of iterate over all of the items, okay? For each item in the list, you can say, hey, go through, give me the first 12 and then quit out. Over here, you can say, hey, for the generator, go through the first 12 and quit out. At this point, the generator, once it's done kind of these first 12 values, it has completely forgotten, or not first 12 values, I guess first 7 values or whatever. It has completely forgotten the values that it has already generated. Okay, so it's the set of instructions that says, I know what I'm going to give you next. If I already told you something, I have no recollection what I told you. Okay, if you didn't keep track of it, that's on you. Okay, so that's the generator expression. Okay, if you say, hey, give me the sum of everything, okay, you can call, hey, I want the sum of the entire generator expression, sum of G. And then the generator expression is going to work hard, figure out all of these things, add them all up, okay? You can do the same thing for sum L, okay? But this is going to be the entire list. So you get 2 different values because this generator expression, it's leaving off, it's going to start at 16. So it has forgotten that these were numbers that it generated. So it just says for everything else, it adds up to here, whereas the list has the entire thing, okay? Now if I just say, hey, list start at 16 and so on and so forth, then we get the exact same number, okay? Now that the generator is done, finished generating everything that it was asked of it, if you ask, hey, give me the sum here, it's going to say what? There's nothing left, okay? Whereas again, the list is unaffected, all right? So you might wonder oh, why would I ever want to use a generator expression? That sure seems like a lot more work on my part and things like that. It is. It's a lot more work on your part as the programmer to kind of keep track. Sure, certainly lists are easier for the programmer, but if you're dealing with some really, really, really big things, okay, on the order of millions, and you don't necessarily need to know everything from the first down to the last, okay? You just need this thing to kind of exist. And then when you need something, maybe you can call it, then a generator expression might be the way to go, okay? All right, Python also allows for something, wait, let me give you your next answer. Next answer is C, C as in cat, C as in cat. Second answer. All right, Python allows for something called a lambda function, okay? Sometimes you want to do something to, I don't know, some kind of object, right? But you don't feel like defining an entirely new function. You can do define function this, blah, 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 and, create a function that's going to return something there, okay? But if it's a really short function that's just going to do a small little thing, you can just create something called the lambda function, okay? Map is kind of like, in R we have an apply thing, but basically you take a function and it's going to apply this function to kind of every object in the iterable, okay? So the map function does map. You give it the name of a function and then an iterable, and it's going to basically run the function on the iterable, okay? And then and this object itself is iterable. So so let me just show you a couple examples. Okay, I'm going to do some stuff with regular expressions. If you're not familiar with regular expressions, don't worry too much. But there's a few things, like with a regular expression, you could say search for, if you have multiple spaces, just replace it with one space. Okay, this would be, we're saying substitute /s is a space character, and plus means one or more. And if you have like multiple consecutive spaces, just replace it with one s. So if so here's a function called replace space, and I'm going to run it on this thing that says hello Alabama, and then I run it. Invalid escape sequence. Does that work? I don't know. Okay. I have to figure out why this is. I'm getting this invalid escape sequence. It should be okay. I don't know. All right. So anyway, here hello space 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 Alabama just becomes hello space Alabama. Okay. Over here, I don't know. I was just feeling like typing some words or the some states out here. Okay. So here I got a list of strings here, and I'm going to call map on this thing. Okay. When I do map, it just gives me back a map object. Okay. So when you call map with a function and an iterable, this creates a generator object. All right. So remember, it's like a list comprehension, but it's lazy. So it's not going to give you everything until you ask for everything. Now you can just take the generator object and put it into a list, and it'll do it. But here I can just say, give me the next thing, hello Alabama. Then we do the next thing, I don't know, Georgia, there were no spaces there. And then we can just say for each item in this whole thing, it can iterate through the whole thing. Okay. And a generator object, you can just kind of take the generator object and throw it into a list. And then it basically converts the generator object into a list comprehension, and it evaluates the whole thing. Okay, so I guess I could have written that back here when we were distinguishing between a generator. If up here I created this generator here, so again G is just a generator, but if you just call list on G, then it will evaluate and basically turn it into a list comprehension. So, so a lot of things create generator objects, like the map function. Okay, creates a generator, and then it only, again, because as far as Python knows, it doesn't know whether the function is easy or complicated, right? You might have a function that takes a long time for each thing, and it says, well, if you guys, I don't want to evaluate all of these things unless I really actually have to, or something like that. Okay, so anyway, this function, replace space, is such a simple function. You know, we just said, hey, substitute multiple spaces with a single space. That I don't actually have to, it might not even be worthy of being its own named function. So we can create a lambda function, okay? And a lambda function looks like this. It's basically an unnamed generic function, okay? A lambda function, it says, hey, take in some argument x, and the thing you're going to return is going to be this expression. Substitute one or more spaces with a single space, and then it works. And it gives us basically the same exact output as having a named function, replace space, and here I have this, okay? We can take this, and here's the lambda function where what it's going to return is just the string in title case, okay? Title case just capitalizes the first letter after each space here, okay? So it didn't mess with any of the spaces, okay? But it changed this lowercase c to a capital C, this lowercase s to a capital S, this lowercase v to a capital V, and so on and so forth. Okay. All right. If you want, you can have lambda functions that take in multiple things. So here I've got a lambda function that takes in an argument x and y, and it's going to return the sum. And so I have to provide arguments for x, values 1, 2, 3, arguments for y, 100, 200, 300, and it's going to evaluate these things, both of them. And we get 101, 202, and 303. It returns all of that. Okay. Okay. All right. Well, this last thing is on sets. You can do set operations and stuff. It's a set is kind of like, it's like a, I don't know, it's like a list or a tuple, but it's unordered, okay, and no repeats, okay. So here I got A, B, C, D, E, F, G, A, B, C, and I say make a set out of that, right? It treats this string as a bunch of individual characters, and it's unordered, no repeats. So even though I got A, B, C again, it's got A, B, C. All right, set 2 is going to be F, G, H, I, J. So here's set 2, and then you have like set operations, right? So you can find the intersection, you can find the union, you can find the set difference, what's in set 1 but not in set 2, okay? What's in set 2 but not in set 1, okay? Set 1 exclusive or set 2, what's in set 1 but not set 2, plus what's in set 2, basically what's unique, all right? What is not in common, okay? So F and G are in common, so those get removed, right? Then you can also just kind of check, does a value exist in set 1, okay? Here's another set, this is one thing a subset of the other, is one set fully contained in the other. You can add an element to a set. These are all just different set operations. So it feels strange, like, well, when am I ever going to use this? Okay, so here's a couple examples where you might use a set, okay? So here I've got, sets are created using curly braces without colons. So curly braces are used to create dictionaries, but you have a colon between the key and the value. And if you don't use a colon in there, then it becomes a set, okay? So here I got data 1, 2, 3, 4, 5. You can filter out values. Here's a set of values I want to filter out. So we can say for just the filtered set is list comprehension, give me X for X in the data if X is not in the set to exclude. All right, so here we go. Here's my filtered values, okay? You have a bunch of lists and you want to find everything that is unique, okay, among them. So I've got list 1 is 1, 2, 3, list 2 is 3, 4, 5, list 3 is 5, 6, 7, okay? And so what is, no duplicates. You just turn everything into a list and you just kind of, what's the union of everything here with, if you turn everything into a set, you take the union of everything, now you get everything, no duplicates. I don't know, there's probably a lot more things you could use sets for, but these are just a couple examples here. All right, we will end there.